Here's problem number 2 on the sample test. An 8,000 Newton shark is supported by a cable attached to a 4-meter rod that weighs 3,000 newtons. Calculate the tension in the tie rope between the wall and the rod if it is holding the system in the position shown. Alright, first thing we want to do is a free body diagram, and we'll indicate this 8,000 Newton force for the shark. And we know that the rod itself weighs 3,000 newtons. That'll act at its center of mass, right in the middle. We're going to have a force of tension going along this cord here. And then we're going to have a resultant force at the pivot, which we're going to divide into a vertical and horizontal component. And for that matter, to make everything x and y, let's also break up our tension force into vertical and horizontal. So we're going to have a vertical force here equal to t sine 20 degrees, and a horizontal component here to the left, if I can get this to right, equal to t cosine 20 degrees. Okay, so there's our free body diagram. And if we were just to consider forces, we could say that the summation of all the forces in the x direction is equal to 0, and we would have h minus t cosine 20 degrees. So that would prove that h is equal to t cosine 20 degrees, at least in magnitude. But that's all we can say about that, and we don't know h and t, so that's good information for later. If we look at the vertical direction, summation of all the forces in the y direction should be 0, and we have a v going up and a t sine 20 also going up, and then we have two forces going down, 3,000 newtons for the weight of the beam and 8,000 newtons for the weight of the shark. So v is going to equal 11,000 minus t sine 20. Nice to know. Always want to know that, but we still don't know what t is, so we still can't find out what v is. So we're going to have to use torques, and we need to choose a point whose line of action will eliminate the most unknowns that we have. Our choices are either A or B. B would be good because it would eliminate T from consideration, but A is even better because it eliminates V and H from consideration. So we're going to look at point A. The summation of all the torques about A should be 0. But we do have torques. We have the torque due to this 3,000 Newton force with a moment arm of this. If the beam is 4 meters, then this distance, this hypotenuse is 2 meters. So this distance to the line of action of that force is going to be 2 times the cosine of 60, which would be 1 meter. And then we have the shark force and the t sine 20, and that's the line of action is this vertical line, and its moment arm is this distance, which is going to be 4 cosine 60, which is 2 meters. And then we have the t cosine 20 force, line of action here, and the distance to that line of action is this green distance, which is going to be equal to 4 times the sine of 60. And that is equal to what? Let me write 3.464 meters. So those are our respective moment arms for the torques about point A. So if we continue this, we have a positive torque from the T cosine 20. So I have T cosine 20 times its moment arm, 3.464. We have another positive torque from the T sine 20, moment arm of 2. And then we have two negative torques. We have the 3,000 newtons with a moment arm of 1, and we have the 8,000 newtons with a moment arm of 2. So we have that 0 is equal to T times 3.464 times the cosine of 20 plus 2 times the sine of 20 minus 3,000 minus 16,000 minus 19,000. Okay, all this stuff right here is 3.939. So, solving for T, we have that T is equal to 19,000 divided by 3.939, and that is equal to 4,823 newtons. So that is the tension in the tie rope between the wall and the rod, 4,823 newtons. We want to find the horizontal and vertical forces at the base of the rod and the angle for the resultant force at the base of the rod as well. So let's do that next. We have that H is equal to T cosine 20, so that's equal to 4,823 times the cosine of 20, and what is that? 4,532 newtons. So that's our horizontal component at the base. We had that the vertical is 11,000 minus T cosine or sine 20. So that's 11,000 minus 4,823 sine 20. And that is what? 9,350 newtons. So that's the horizontal and vertical components at the base. We have 9,350 vertical, 4,532 newtons horizontally, and our resultant force will be the vector sum of those two, going like that. So what's the angle for that? Well, angle will be the inverse tangent of the vertical component over the horizontal component. So that's going to be the inverse tangent of 9,350 over 4,532, and that's equal to 64.1 degrees. So even though the beam is at a 60-degree angle, this resultant force is coming up above the beam at a 64.1 degree angle. And that's because the beam has weight. So that's our answer. That's for part C. That is the angle of the resultant force at the base of the rod, 64.1 degrees.